As India takes the information superhighway towards realizing its digital dreams, it joins the ranks of global consortium of IT-enabled nations that are lighting the path. One of the fields that has gained tremendous ground in the last few decades is big data and big data analysis. What do these terms mean? And how do they affect every one of us in some form or the other? Keep watching to know more. Throughout the history of the world, human beings have been collecting information in some form or the other. 20,000 years ago, Paleolithic tribes people kept tallies on pieces of bone. They would compare sticks and notches to carry out rudimentary calculations, enabling them to make predictions such as how long their food supplies would last. In 2400 BC, the Babylonians used the abacus to do the same. Thousands of years later, human beings developed a new way to preserve information through words written on pages and books. They began to be stored in large numbers in libraries, where they could be accessed and used by any member of the public. Libraries are a way to store and share information that continues till date. In the 20th century, a change was brewing. Wireless and radio technologies were being developed to convey information. In 1926, Nikola Tesla predicted that when wireless technology is perfectly applied, the whole Earth will be converted into a huge brain. And the instruments through which we shall be able to do this will be amazingly simple compared to our present telephone. A man will be able to carry one in his vest pocket. Did Tesla's prediction come true? It's clear everywhere we look. In this digital era, there is a new wave of information sweeping us, and it is called big data. Big data refers to the massive amount of information that we, as humans, have collected and continue to generate on a daily basis. Today, the internet stores all kinds of information from academic subjects like physical and social sciences to current affairs, ever-changing data like stock markets or the weather, and so much more. We ourselves generate a huge amount of personal information, from typed documents, official records, to photos we take from our mobile phones. How is it all stored? Unlike libraries where information was stored as words and numbers in books, today it is stored as digital packets measured in bytes. So a 3-minute song stored in your mobile phone could be a few megabytes. A film could be a few hundred megabytes. The size of digital file carrying data about the human genome could be trillions of times that size. Now think of all the data in the world. Can you imagine the amount we humans have collected till date? For this, we will have to move beyond megabytes, past gigabytes and terabytes and petabytes. At 2 petabytes, you can include all the data available in every academic library in a country like the US. We need to still keep moving up the scale, past exabytes and reach zettabytes. Approximately 3.6 zettabytes to be precise. Obviously, this amount of data has to be stored somewhere where it can be accessed quickly and easily. That's where the development of computer software and hardware has played a huge role. India's history of building computers to handle big data goes back as far as the 1950s. That's when Professor Mahalanobis of the Indian Statistical Institute at Calcutta first thought of using computers for population census. At first, India purchased computers from the West, like the British-made HEC 2M. But the idea was always to make computers of one's own. In 1960, India's first indigenous digital computer was made at the Tata Institute of Fundamental Research, or TIFR. It was called TIFRAC. and it could store a maximum of 1 kilobyte and process about 1024 words. But the world was going digital at an electric pace, and big data was accumulating faster than it could be processed. Therefore, India realized that it would have to not just build computers, but supercomputers to keep up. That fell to the technocrats at CDAC, or the Center for Development of Advanced Computing.
Why can't we develop our own supercomputer? We have done well in the nuclear program, Dr. Bhabha, and then we have done in space program with Vikram Sarabhai. So let us give this challenge to our Indian scientists so that let's develop our own supercomputer.
And so, in the late 1980s, India's finest scientists and computer engineers came together to build India's first completely indigenous supercomputer. By 1991, they had built the Param 8000, a 1 gigaflop supercomputer. It was just the beginning. Over the next 3 decades, the Param series kept India at par with global supercomputing technology. There was the Param 10,000. Then came Param Padma, Param Yuva, and Param Yuva 2, which is the latest and most powerful supercomputer of India. Now that we have the technology, let's understand what can big data actually do for us. Big data computing can allow us to get the big picture that would otherwise be difficult to do without computers. For example, in keeping India safe from crime and terror, every day, hundreds and millions of bytes of data is created by surveillance of public through CCTVs and monitoring online communications. Generating this data is easy, but how can it be studied? How can any human being, or even a group of people, possibly go through hundreds of hours of footage, emails, and social media communications?
Now, just installing the CCTV will not help, because we need to also analyze these videos. If a video is being captured on a continuous real-time basis, we can understand the amount of video data that the country has. Okay, but what are we going to do with this data unless we are able to analyze all this data? Okay, so the analysis will require huge computing power, and these computers will actually help us in addressing these type of issues and problems as well.
As seen in its use for maintaining law and order, big data analysis steps in where human ability gets exhausted. Nowhere is this more true than in fields of pure sciences and academic research.
Actually, we know that innovation is the key to any country for being ahead or being competitive with other countries in the global world. And we know that for innovation, research and development, that is R&D, is key. And R&D in today's modern era actually is extensively being carried out by supercomputers. With the advancement of supercomputing, a new model for R&D has been infused in the research and development area, and that is simulation and modeling. Supercomputers actually enable simulation and modeling of complex data and enable us actually to model the real scenarios of the world and simulate it on a supercomputer to enable R&D.
In recent decades, fields such as high-energy physics, biology, astronomy, and many others have used computers in a big way to do their research. This has generated a massive amount of data. In fact, such kinds of big data analysis have led to an entirely new field of science called bioinformatics, where biology meets computers.
If you look at how biology has evolved over the past 2 decades or so, it has changed from something which was purely an experimental science to a high-end computational domain basically. Now, why has this happened? This has basically happened because a lot of high throughput methodologies and techniques have been applied in the life sciences. A lot of automation is coming into life sciences. Just to give you an example, there is something which is called as a genome sequencing. A genome is a kind of information carrier for every organism, whether it's plants or animals or livestock or microorganisms for that matter. Sequencing a genome gives you a lot of information about the entire blueprint of the organism. Now, just to give an example of how genome sequencing has changed over the last 2 decades, the human genome was sequenced in 2000, and it took something like 13 years to sequence it. It took something like 23 labs across the world to sequence it. It took something like $500 million. Today you can do it with one machine. You can do it in less than 3 days, and you can do it for $10,000.
How does genome sequencing qualify for the tag of big data? That's because DNA, for example, human DNA, contains billions of chemical combinations or protein base pairs that are important to study when mapping the human genome. These billions of data points can only be processed by supercomputers.
Human genome analysis is actually an petascale to an exascale problem. For example, the breast cancer study which we are doing currently, it's a very small study concerning only the genes involved in the breast cancer regulation. Now, if you are trying to expand it out to the entire human genome, you could require something like a petascale or exascale system to really do a complete analysis of the entire human genome, basically.
Mapping genomes is just one example, because sometimes the problems of big data are so huge, they need the whole world to join in. In 2012, the world woke up to one of the most stunning scientific discoveries in recent times. Physicists hunting for the smallest units of matter stumbled upon the Higgs boson, a subatomic particle so tiny it needed massive experiments to be conducted by the Large Hadron Collider, or LHC. When the LHC is running, every second nearly 600 trillion pieces of data are generated. Far from any single research lab decoding the LHC's results, the task needs help from the whole world. In order to do that, a global network has been designed to not only store and back up big data generated from the LHC experiment, but also to send it to different parts of the world, where scientists and physicists can analyze it. This network is called the Worldwide LHC Computing Grid, or WLCG. The grid draws on the collective computing resources around the world, using different centers or tiers for storage, backup, and processing power.
We're here in the CERN Computer Center. This is called the Tier 0, and this is where the data will arrive, where a first analysis is done, and from here it's distributed all around the world. So in the last year of running, the LHC produced something like 25 petabytes of data. This is 25 million gigabytes of data. So even though we have a big computer center here, it's not enough to analyze everything. Well, high energy physics is a global community. It's one community spread all over the world. This is one of the reasons it produced communication technology like the web. And the next step from the web, which is sharing information, was the grid, which is sharing computing power.
Every year, the LHC generates 30 petabytes of data. It is all sent to researchers around the world, including India.
You can see it here, starting at CERN near Lake Geneva. And if I zoom out, you can see the arrows are data transfers. And you can see transferring across Europe. And if I zoom out further, you will see data transfers heading towards the Americas and heading towards Asia. So the data generated at CERN is distributed all over the world for analysis to places called Tier 2s. And in the case of the CMS and ALICE experiments, data is distributed to India. And I can show you the CMS center in Mumbai here. So this shows how an Indian site, in this case Mumbai, is connected to the global physics analysis for LHC.
In India, the data is received in Kolkata by the Variable Energy Cyclotron Center, or VECC, and in Mumbai at the Tata Institute of Fundamental Research. Servers at these locations act as repositories that Indian researchers can access depending on their field of study.
What you see behind us in these racks are a set of computing resources. There are many computers which are the basic number crunching machines, and there's a huge rack of storage space which is nearly 500 terabytes of storage. And then of course we have all the network which connects these all that is in a local area network and then connects to the external world in a high speed network.
Big data is changing the way we do science. But how does it impact the common man and woman? Find out after the break.
The prolific British poet and story writer Joseph Rudyard Kipling, one of the first masters of short stories in English. In 1894 appeared his Jungle Book, which became a children's classic all over the world. Kim, the story of Kimball O'Hara and his adventures in the Himalayas, is perhaps his most felicitous work published. Set in and concerned with India he had come to know and love so well. In 1907, Kipling became the first English language writer to receive the Nobel Prize for Literature.
Big data is a buzzword in the 21st century. For digital India, it is a powerful concept that could change the lives of even the poorest of the poor. Thanks to big data and supercomputing, governance is getting a major boost in delivering public welfare schemes.
The back-end digitization and the digital media and the computerization of all various projects is a way to make things very easily accessible to citizens as well as to streamline a lot of services.
Through the Aadhaar number, each citizen gets a unique ID. If all the billion-plus IDs are processed through big data computation, imagine the kind of transformation that could take place. In fact, it's already happening in the fields like healthcare, food security and banking, where multiple databases have access to an Aadhaar holder's information. For example, if a person is from a below poverty line family, his or her Aadhaar can authenticate its eligibility for subsidized food grains. Or Aadhaar can help health workers keep track of the prenatal needs of an expectant mother in a village. Aadhaar can facilitate the issuing of bank loans, filing tax returns, or even authenticate one's right to vote. This is possible thanks to nationally accessible and highly secure infrastructure set up by the National Informatics Center throughout the country. This includes NIC's cloud as well as data centers across India.
So the easiest way to do it is to employ IT at the back end. And cloud has become a big enabler for that IT. So that each government department doesn't need to buy their own services, they don't need to set up their own data centers, they don't need to really put huge infra in place, so that there's a back-end infra, it's like an IT infra that we are giving that is easily available to the government. They can very easily just say that we need 5 servers today or 10 servers. They start off on their application.
Today, India's big data infrastructure is in place to facilitate governance, scientific research, and many other areas crucial to the economic progress of India, such as weather prediction. Big data computation and analysis is the cornerstone of current day weather forecasting. This is because today's instruments to collect weather data are based not just on visual observation or measurement of things like temperature and pressure. In fact, satellites and radar are taking weather observation to a whole new level. How? Different weather-related objects like rain-bearing clouds or fog formations emit different types of electromagnetic radiations, or radiances. Satellites are equipped with sensors to pick up energy amounts across different spectral bands. These energy amounts, or radiances, are then recorded.
What we have onboard satellites are not the cameras, they are called imagers and sounders. Imagers, they keep on scanning the Earth from one point to the other point at the bottom, say if you start from the top to the bottom, or if you start from bottom to the top. And these whatever radiances are observed by the satellite sensor while this is scanning, they are in the form of digital data. So it is not like a one-shot camera image. So it takes about 26 minutes to get a satellite image.
The satellite digital information is binary in codes of zeros and ones, stored as bits and bytes. These bits and bytes of raw data are transmitted down from the satellite to IMD's Earth station. Here, they are passed through machines to process it, to make sense of it.
During processing, we have assigned right value of latitude, longitude to that particular locations. Along with the energy amount, we have to apply certain number of correction to reach the exact value radiated from the target. Means our target is a cloud, our target is a sea, or our target is Earth.
These machines also adjust for any changes in information along its long journey of as much as 36,000 kilometers.
So definitely certain amount of inaccuracy incur in that. To compensate that inaccuracy, we applied corrections, atmospheric corrections, zenith angle corrections, and this is now used for the further processing.
Daily nearly 400 GB data is generated here. It is processed into meaningful information. For example, images of weather conditions over a particular area. How exactly does all this happen? How does the big data generated by weather instruments make for a forecast that you and I can use? Join us after the break to know more.
A labyrinth of hundreds of narrow stairway passages is a significant and historical component of what you popularly know as Bara Imambara. Some of these narrow stairways have dead ends, some end at precipitous drops, while others lead to entrance or exit points. Historically, Bhul Bhulaiya was constructed to confuse the enemy intruder, and the narrow lanes of the labyrinth can make anyone feel lost. The structure contains various strategically built hollows in the corridors.
Did you know that in order to generate a weather forecast every day, it takes a lot of big data to analyze in a very short amount of time? How do forecasters do this? Luckily, they have a powerful ally because India is one of the few countries in the world to have its own supercomputing technology. Supercomputers allow for a phenomenon called numerical weather prediction, where large volumes of weather data are fed into complex mathematical equations and algorithms. Supercomputers are able to do such complicated mathematics much faster than you and I. At the end of this process, you get a mathematical model or a picture of what the future weather might look like. Digital era forecasters like those at IMD use a combination of numerical weather prediction and their own meteorological expertise to devise a forecast.
Now, with these information from the numerical models and the information from the observing systems, the forecaster among themselves confer with each other with the help of a video conferencing and take a decision about the today's weather and the forecast for next 5 days.
In fact, so efficient has ICT made forecasting that it has led to the phenomenon of nowcasting, or the preparation of extremely short-term weather forecasts of as little as 2 hours. Nowcasting is very useful to track moving weather phenomena like fast-moving winds, sweeping rain-carrying clouds that may lead to heavy downpour in a localized region. If you were a fisherman or a farmer or even someone who worked on an offshore oil rig, nowcasting would be especially useful. The era of big data has only just begun, and things will only get bigger and better as the technology to use it improves. For India especially, progress and development is linked closely to big data. So it's time to build our IT capability and dream big. Please send your suggestions and comments to Vigyan Prasar, A50, Institutional Area, Sector 62, Noida, 201309. You can also email us at info@vigyanprasar.gov.in.